My name is John Roberts, and I'm from Laing O'Rourke. I'm part of the Engineering Excellence Group, like Gavin is.
My name's David Lewis. I'm an architect at MBBJ Architects. And Laing O'Rourke and MBBJ have been working together on a whole range of projects. And today we're going to talk about two of them. And this is about the benefits of off-site fabrication. And what I'll do is give an introduction to that, then we'll talk about the projects in particular, and then we'll talk about perhaps where the world's going with those. So historically, the idea of off-site fabrication is nothing new. The Romans used to use off-site fabrication to build forts. When they would go and invade and conquer someone, they would take their forts with them in pieces and erect them when they got there. The idea of war actually intensifies the use of prefabrication and off-site fabrication because things are needed urgently. And that was no different in the Crimean War, where Brunel developed the hospitals, which were made in England and then taken off to the Crimea and assembled on site. Now, those are about creating buildings from off-site fabrication in intense circumstances. I mean, they've also been done whimsically, and Buckminster Fuller was great at sort of designing prefabricated structures. But the one I quite like is this one, which was designed out of love. This is a guy called Mannings, whose son went off to Australia, and rather than top up his prepaid phone card or give him a credit card, he actually built him a house in packs. And the guy went off and assembled it when he got to Australia. And actually this became so popular that the guy set up a whole business building this stuff. But what are we talking about? The brick, the standard brick, is a modular, off-site fabricated piece of the building. And I think what we're going to talk about as we go through this is really about the scale and the size that off-site fabrication and the benefits that will bring to the building industry.
It was interesting David had the picture of the brick in there, because that's matched up precisely with some of the slides that I've been using. If you go down a modular route, you really have to respect the module, and right from the word go, start thinking about its impact. And we all know the dimensions of a brick. But let's consider these key points. And tell me if I'm going too fast for you. Brick buildings look like they're made of bricks because they're made of bricks. Next one, bricks are made in brick factories, and then finally, bricks are laid by bricklayers. I can go over that again. Well, let's do it slide by slide. So moving on. Let's think about brick buildings looking like they are made of bricks because they're made of bricks. On the left is a building. Actually, I have a sort of funny relationship with Frank Gehry. Mainly, I demolished a building by him once, which is quite nice. I'm sure he feels the same way about me. But if you went into that evidently not brick building, you would probably go in there and discover that the doors are all widths driven by units of bricks. And actually, the brick as a module has so invaded so many aspects of construction that actually a lot of the things that are set out through every building are set by that module. And in a similar way, once you start adopting other modules, you really have to respect those and their tolerances and their sizes and their manufacturing requirements in everything you do. So it affects your product. Similarly, you can't just go away and use the same sort of equipment. You need to have a specialist plant to produce whatever your materials are. So you've got to have your brick factory. So then the next click will, your plant and your process are going to be completely affected by that. And our Explore factory is now moving that on at Steetley near Worksop. And finally, bricks are laid by bricklayers. The more you move into modules, the more you have to think about specialist skills that are associated with that. They are trained in different ways from just general labour, which is the way construction no doubt started. So if you click again, we spend a lot of our time now talking about our people and the fact that increasingly we're having to teach them more about logistics, design management, coordination, the safety issues around heavy lifting. Those are the activities that increasingly, as we move towards a more modular future, are starting to dominate rather than the type of activities we had before. So you really have to think about how you develop the people who are going to be using these modules. So the way we play this through, I showed this earlier today, the way we play this through is what used to be called the UBO. We now quite often refer it to as the value proposition. And so moving on, I think it's bigger next. the three bits of actually talking about design for manufacture and assembly. And it tends to be that the other three areas, digital engineering, which is sometimes called BIM, the vertical integration of the company, which is about making sure that all parts of the process, both our design supply chain are aware of the issues around it, all the way through to the plant we use with Select, are all integrated behind this idea of using a modular off-site approach. And also Engineering Excellence Group, which is the part I come from, is really about being able to stand on a stage with an architect and hopefully be relatively coherent about talking about some of the issues. I'll leave you to judge. But all those things can be seen as supporting DFMA with the next click, but also at the same time, what you find very rapidly is actually they all interact with each other. So one more. There'll be an example soon, for instance, where the engineering excellence team in innovation terms is working directly with the supply chain, and also all of those things feed off each other. DFMA, some of you were here earlier, I know, but really we set the internal targets of trying to achieve at least 70% of our product delivered through off-site manufacture. That will cause a 60% of reduction of labour on site. I do actually notice that, having walked around a lot of Lang O'Rourke sites in the last 18 months, they are a bit spooky at times. You wonder where everybody's gone, but actually somehow they all seem to get built, hopefully, with this 30% reduction in programme that we seem to deliver during that. So it actually seems to work. One of the other key things I would flag up is the fact that we see this as a much safer way of working. We move jobs to much safer environments, much more controlled environments in factories. We take them out of exposed positions with the elements and put better trained people. The people we have remaining on site tend to be better trained than they would have been otherwise. So actually it's a much safer environment.
So we're going to talk about the first of our projects. This is a new hospital at Dumfries and Galloway. It's approximately £200 million construction cost, has to be delivered in 2 years. Very complicated building, very, very short timescale. In terms of the off-site prefabrication, we're using the structural systems of columns and floors. The mechanical systems are all coming together, constructed off-site and then all plugged together on the site. And what I'm going to talk a bit about is the external envelope, which is also about appearance, but also is the external structure. So just in terms of the design for the hospital, traditionally hospitals are sort of big blobs, which is the one on the top left-hand side. And we wanted to break this down. And this hospital sits in a very, very beautiful rural environment. So as you can see through here, we break it down into smaller elements, and we start to bring the landscape in through the hospital. And then we divide the hospital up into its three key components, which is a women and children's block, what we call a technical block, which is where all the sort of big operations and stuff are done, and then the ward blocks, which is the inpatients. And within that, trying to sit within that sort of countryside, we felt that the idea of this sort of low-level pitch roof building is quite key to the way it sits into that environment. So this is sort of an axo of how the building's starting to develop. This is the women and children's, that's the technical block, and these are the wards. The wards resemble sort of rural barns. This roof landscape, when you view it from a distance, all the roofs are slightly offset so that you actually get the idea of a small hamlet. But what we did was, with the three elements, we decided that we would try to differentiate them externally. The wards have a pattern. All the patterns are based upon the surrounding forest. The wards have a linear forest pattern. The main technical block has a broken down tree pattern, and the women and children's has a much softer tree pattern. We also wish to take on board the sort of local materials that are in the area, and within Dumfries there's this very beautiful white sort of, it's a granite stone, and it sits very well in that sort of colour of landscape. In here you can start to see some of the tests we did within a white reconstituted stone panel to try to get some of those tree effects. Now how it manifests itself is, this is the main technical block. This was how we derived the tree pattern. And what's interesting here is that on a technical building in a hospital is that the windows don't all line up. At each different floor level, the functions behind are all very, very different. So we developed a horizontal pattern, And within that, we put a patterning system that reflect the trees. If we look at the women and children's, which is predominantly inpatients, the bedrooms all sit above each other. So we had a linear arrangement here. But here we took this idea of, we took a photograph in the local forest, and it's this idea of a very linear pattern. And then we developed that into a reconstituted stone facade. And then finally on the wards, again, windows tend to sit above each other, and it's using this vertical linear element to represent trees. And all those sort of come together, and we're currently in the process of developing the colouring in more detail and developing the patterning in more detail as we go through this. Now, all this is made off-site and brought to site, even these test panels. And what's quite key about that is the walls themselves. That's the external side. Here you can see a section through the building. The external envelope is the aesthetic side, but internally, it's a sandwich panel, and the internal wall is a structural wall. And what that means for us is within the hospital, there are no external columns on this wall. So we don't have a traditional system of running trunking, skirtings, and everything around a blip that occurs in the external facade. And the other thing about this is the quality of concrete as it arrives on site is so good, we just paint that, even in a hospital environment. So the next project I want to talk about is a project in Cambridge. It's next to Addenbrooke's Hospital. And this is a hotel, a conference centre, a private hospital, and retail facilities. And being in Cambridge, this is slightly different to the previous project insofar as it's quite a conservative client and a conservative area. So we developed a sort of a classical modular system based on some of the buildings already in Cambridge, some of the favourite buildings. And then from that, we developed our 3D models, and we prototyped and tested a whole range of proportions, but also proportions that can be manufactured off-site efficiently within an off-site fabrication system. This then gets developed into elevation treatments, and all the panels, the idea is you try to rationalize the number of different types of panel that you use, which actually, when you have a classical sort of building, that's actually much easier to do. But what's quite key about this is not just the reconstituted stone paneling system, it's the integration of the whole facade into this. So there's an internal system, the external, but also the windows and the transom systems are included in this. And we did various tests and modules for this. And we run this past the planners, who were quite keen on how this would progress. It's also the ability to get depth within an external panel system, and also the idea of a continuous strip, even though sitting behind that is a concrete reinforced panel that doesn't do the same as it does on the outside. And these all come together on site. And these are one of the modules that we currently have been tested, and in terms of colour and testing the waterproofing and testing what we want it to look like on site. So what we're achieving through this system is actually a very, very, very high quality building, but also a building that actually doesn't feel like it's prefabricated.
Just going to talk through some of the background to the manufacturing aspects that contribute towards the frame and also the facade. Within Lang O'Rourke, there's I was discovered about 18 months ago, they have a very strong series of brands that I wasn't aware were really all under one roof. And so Bison, which is a product that's been around for a long time, GRC UK we'll touch on at the end, and also a whole host of things are now being developed under the Explore banner, not just at Steepley, but at several other plants as well. So quickly going through the concrete menu of things we have available, which is this natural starting point for the company, but has then spun into other things. As I said, Bison, I've been specifying that project for 30 years, but then the work done at the Leadenhall project really sparked a lot of thinking about the way we could have smarter concrete products that allowed more rapid construction to be done with less people on site. On the right-hand side, a product which comes off what's called the high-speed carousel at Steepley, which is a lattice plank. Lattice plank, when it rolls out of the factory, has been half the cost of our other products. So it's very efficient to use that high-speed carousel plant. There's only about 6 people involved in the manufacturing of nearly half the output of that factory. On the left-hand side, a product which is more complicated to construct, but we're finding in concert with it, and you've actually got a layout up here of one of the layouts we've been developing. The E6 plank provides a primary strip and allows you to eventually create a completely flat slab that doesn't need any props, which we'll come back to in a minute. And if you click again, the E6 plank is all reliant on this headed bar technology, which we've initially been importing from Norway, but we're now moving into manufacturing it ourselves to bring the cost down for that item, and that allows you to completely. Anyway, that's a view during construction. There are no props in this flat slab system, which is quite remarkable when you see it for the first time. Vertical structure. I don't think we do in situ columns anymore, which saves an awful lot of time, and also twin wall, which is a lattice plank turned over and placed into another plank on the high-speed carousel, is a very efficient way to produce all sorts of walls. So on the left-hand side, along with Mega Plank, which is our replacement for a crinkly tin slab on beams with studs coming through the holes to give the composite action, that provides the complete menu along with our walls, window walls, sandwich panels, and columns for a standard kit of parts that can then be made bespoke and configured for each building. Works very well for hospitals in particular. And then moving beyond that, I mentioned GRC, and just to touch on it, it's a completely different field, but we're moving into much higher use of robotics to allow us to create molds that in future will be allowed, once we've got through the Crossrail project, which will keep it busy for 2 years. I think it's going to be very, very useful for some of our facade products. Okay. We focus a lot into the data, each day, where construction is, what props are needed, who's working where. Because once you start going that fast, you have to be very careful about your planning to make sure you know what materials you need on a day-to-day basis. And then with that, once you get the plant and the modules for bathroom and the smart wall product, which potentially have the wiring in it as well, all those things can be loaded on to each floor as you go, and then you put your propless flat slab over the top of it, and that allows you to preload each floor as you go, creating a sealed environment, which allows you then to move complete construction on each floor level much faster. And potentially the programme for Dumfries and Galloway that's being talked about is 2 years, which if I go back to the job that Lang O'Rourke did down in Tunbridge Wells a few years ago, I think it was 4 years. So almost half the time has been taken out as this menu of pieces has been refined. This is also to mention the fact that we are developing a series of modular plant rooms, which again will take a lot of time, and many trades that are currently on site we'll put them into a standard piece that we'll manufacture off site and bring as a single element to site. The vertically integrated supply chain, very, very important, as I mentioned earlier. I'd focus in particular on Select, who I didn't know were part of Lang O'Rourke until I arrived. They are one of the largest equipment hire companies companies in the UK. A lot of very, very good lifting equipment. And on the next slide, if you go down the modular route, you have to really focus on making sure you have the maximum amount of hook time available. We were talking earlier about blue sky thinking, which is a phrase that you've probably heard of before, but if in Select, it's about whether or not you've got blue sky above you. If you can put a hook above you, you can drop a module in. And that is absolute prerequisite. So increase the amount of time you can get a hook above your head is very, very important. And we've been looking at ways that we can put smart sensors in that start looking at the power output and the peaks and the troughs, that starts looking at the predicting the failure of motors in much the same way as being used in the aerospace industry. So you then send your maintenance crews in at night to swap the engines out on cranes rather than lose a day whilst you wait for somebody to turn up because you can't actually use the crane anymore. And down in the bottom left-hand corner, we've done a lot of studies at Hinckley about improving the outputs of cranes. We've actually been looking at the same things for Dumfries and Galloway, which is another potentially exposed site, and we've been doing a lot of work of thinking there about whether or not we can modify the wind environment and increase our predictive capability of actually, for instance, how do you decide if it's going to be better to have a flat-top crane or a luffer crane? An issue as a consultant I had never climbed into, and it's actually all done on gut reaction at the moment. And we're starting to get some tools in place to allow us to get cleverer decisions around those that start looking at real wind data and real performance of cranes.
Okay, so an integrated design. I mean, there's plenty of conversations around BIM. I think the important thing about that is this is actually how it works with everyone around a table, still talking about design as traditionally designers would do, but also working in a 3D model in real time. And the advantage of this is it ensures we're all sort of joined up. I think where BIM is not properly used, but with off-site manufacture, should be really enhanced, is the number of people BIM brings into the system. So at the moment, it works between the design team and the contractor, but the owner can actually have much more to do with this. And so you could, how he's going to run his building, how the supply chain for him in terms of what he needs in his building, how they're going to actually measure the metrics of the building, all can come within the BIM system. And I think there's a way to go with that.
And collaborative working is one thing, but the other thing that is a must be achieved output from the BIM process increasingly is the flow of data through that process and popping out at the end to become an asset management tool at the end. We have traditionally had a very, very disintegrated confrontational industry, and really BIM has become a key way that we're trying to achieve this data flow, the phrase I've used there, added to, evolving, refining, and then delivered to end users. And really, I think this country's put a fantastic amount of effort into producing work that has made the rest of the world sit up and take notice about this. And I know we are as Lang O'Rourke, our manufacturing side has a different set of requirements, and increasingly that's becoming more and more successful in the fact what we're getting from the supply chain, in getting the right data at the right time. This is a sort of view of digital engineering from the Lang O'Rourke perspective and the kind of things that we're wanting out of it. And the key things that we need is data that we can rely on we need a coordinated design at the top, sequencing 4D information that we can produce 4D models from and attach programs to, absolutely needed from day one. It's almost the first thing that we do when we start working on a tender. Logistics planning, all linked in. Constructability, we're doing more and more modelling of rebar in 3D. The visualization is still very important, actually, on all sorts of aspects, partly for selling things to clients, communicating with the rest of the team, but also site safety. We do make a lot of use of that on snapshots on a week-by-week basis, so people, when they're having their site inductions, can know exactly where they're going. Integrating, costing, and then starting to move on into the facilities management. So there's a whole host of data that all needs to be coordinated rather than having separate families of data as so often has happened in the past. And going back a few years ago, actually one of the reasons I was talking to Lang O'Rourke back then was the fact that in advance of there being a plan of work available, a digital plan of work available in this for the industry generally, Lang O'Rourke had pushed ahead and actually managed to produce their own, which they were trying to drive their supply chain to use. Increasingly now, we've had some input into the one that's been produced. We're very keen now that the whole of the industry moves over to be using the digital plan of work that's now being produced.
Okay. So just on the plan of work, when I first started in this as an architect, you'd start at the beginning of the project, and actually the building was a long way off, realising it was quite a way down the line. And partly that's because the design process, sort of as set out in a plan of work, it is linear. It all runs in series. So you complete one stage, then you sign it, then you start the next stage. Now, I think what off-site manufacture allows us to do is actually zoom in on the end product. You can actually know what you're going to deliver with much more certainty, not just when you start the technical information, but actually from day one. When you start concept design, if you start concept design, understanding the way in which you're going to deliver it through an off-site manufacturing process, the quality of the building improves, I believe, because you actually have a better understanding of what it's going to look like at the end. So if that's the traditional plan of work, what really happens is dealing with off-site manufacture actually condenses that and actually starts to bring things working much more in parallel. Now the issues with that, so you start the concept design, and your developed design and your technical design is actually brought much further forward. Now what that does though is it creates a burden on a number of areas where you need increased resources, because you're not just taking one stage through and the same resource people and then they start the next stage. You actually end up bringing your technical resources through to the much earlier stage. And I think that's something that needs to be recognised and is not truly understood in a plan of work. And I think part of that is there's a level of risk. The reward of off-site manufacture is you've brought the end date forward. The risk is that, say, you haven't yet got planning consent and yet you're doing your technical work. So you've increased the resource before you actually have passed the sort of risk stages. The other way of looking at it is, if that's the traditional route, is that you don't decrease the actual overall program, but you spend much more time in developing the design. And this is one of the things we find, is that actually the outcome of that gives us a much better surety of what the product's going to be like. But also we have time to develop many, many options around where this building is going to go. And so you get a much better, a much more efficient result.
And this is a slide that I've often used, which is the fact that increasingly we have to see ourselves as not just handing over a physical asset, we also have to hand over a digital asset at the same time, or perhaps even before, as part of the onboarding of the client and the operators onto the job. I always say that, first of all, it's a standard piece, and you know a piece of Lego is going to fit because it's standard, and they've got a smile on their face because hopefully it's going to be fun and decrease the amount of conflict.
So just sort of moving on to that, and where next? And I say where next, but actually this is happening now, but I don't think it's necessarily mainstream. This is a design for a sports stadium in China. We developed the external envelope through a series of sketches, models, and everything else which is traditional, but also using what we call computational design. And that takes parametric design and develops shapes. But what's key about it as well is the data you can keep within a computational design system, the data it contains. So what we can do really, really quickly is we can run a lot of options on how we might want that building form to be. Not just in terms of what we visually want it to look like and perhaps how its performance is in terms of a building, but actually its performance in terms of costs and efficiency in production. And these two options here were the most expensive option. I think when we got down to about 21 trusses, we'd reduced about 30% of the cost of the building. And this data is contained within a computational design. So we're constantly getting readouts. Every time we adjust the building, we get a readout of where we think this building is. But then what we can do with that, we take that from the computational design into the BIM process, into Revit, say, and from that we can produce the technical drawings. But also what's key to that is actually, and what we're doing on Dumfries and Galloway, is these drawings then go into the manufacturing process. This is a cutting list. It's more than a cutting list. It actually went to the computer that was actually cutting and then welding the various structural elements of that sort of petal shape. And this is where the building currently is on site. But as I said, 30% efficiency on what our original design was. And we worked that through using the computational design. Slightly more close-up view of that. So just to sort of where I think this is going now, this is a sort of traditional design meeting. But with computational design and understanding what the end result is going to be in terms of off-site manufacture, we're developing the computer models in line with sort of the general design process of drawings and producing models. What's interesting on this one is actually it's a sort of a bit of an architect's insight manufacture where this goes straight off to our laser cutter and we produce models sort of very, very quickly. But we have this design process internally, and then this feeds directly into how this building is going to be produced. So it's this linear element that goes through the off-site fabrication process.
And for us, we've been, over the last 5 years, learning how to deal with this beast and exactly how to support projects with it. And now as things are starting to speed up, we move into the final couple of slides, which is now the fact that Explore number 1 is there. We're just about to start digging for the Advanced Manufacturing Centre. basically a second factory alongside it doing completely different things. It's going to be much more involved in mechanical internal fittings and also modular housing. If you move on to the next piece, you can see the factory in the bottom left-hand corner. And really, if you go to explore now, as you drive in, you see these two prototypes there, one of which is a house, which is actually probably not our target market. The modular housing solution we're looking at is probably it's going to be a steel frame one, and it's aimed at sort of 6 stories to 20 stories. The fun thing with that bit there, which is a bit strange looking, but it's actually, if you imagine, it's the top of a 20-story building, all constructed without people putting their feet down on the ground, because they wouldn't be able to if it was 20 stories. So we kind of proved it all went together. But from our point of view, a huge amount of stuff to learn around robotics, around tolerances, and an increased amount of data richness in terms of what we're doing, and a lot more smart sensors. So this journey only is just beginning, I think.
Yes, I think so, that's true.